Let's do this. Left at unit. We got unit 2 trigonometry. I dislike trigonometry, but it will come handy later on. I've already studied this, but god damn it. You got no memory recollection whatsoever. So you're gonna have to stick with me in the videos if you want, or if you want, you can skip it.
So just like that, we have been able to establish that cosine. In this video, we're going to figure out what the sine, cosine, and tangent of two very important angles are. Angles that you'll see a lot in your trigonometric and just in general in your regular life. So these are the angles pi over 3 radians and pi over 6 radians. And sometimes it's useful to visualize them as degrees. Pi over 3, you might remember pi radians is 180 degrees. So you divide that by 3, this is equivalent to 60 degrees. And once again, 180 degrees, which is the same thing as pi radians divided by 6, is the same thing as 30 degrees. Now I'm going to do it using the unit circle definition of trig functions. But to help us there, I'm going to give us a little bit of a reminder of what some of you might be familiar with as 30, 60, 90 triangles, which I guess we could also call pi over 6.
Allah Akbar, Allah Akbar. Allah Akbar, Allah Akbar. Allah Akbar, Allah Akbar. أشهد أن لا إله إلا الله. أشهد أن لا إله إلا الله. أشهد أن محمد رسول الله. أشهد أن محمد رسول الله. لا حول ولا قوة إلا بالله. 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 الله أكبر، الله أكبر. لا إله إلا الله، أشهد أن لا إله إلا الله، أشهد أن محمدا عبده ورسوله. سلام دين محمد صلى الله عليه وسلم. كلام يا محمد الله مرحبا. صلى الله عليه وسلم. الفضيلة بعث الله مقام. لكن لا تخف من
pi over 3, pi over 2 triangles. And so let me just draw one, because this is going to be really helpful in establishing these trig functions using the unit circle definition. So let me draw a triangle here. It's hand drawn, so it's not as neat as it could be. So this right over here is a right angle. And let's say that this one is pi over 3 radians, which is the same thing as 60 degrees. And this one over here is pi over 6 radians, which is the same thing as 30 degrees. Now, let's also say that the longest side, the hypotenuse here, has length 1. Now, to help us think about what the other two sides are, what I'm going to do is flip this triangle over this side right over here and essentially construct a mirror image. So because this right over here is a mirror image, we immediately know a few things. We know that this length right over here is going to be congruent to this length over here. And let me actually finish drawing the entire triangle. It's going to look something like this. And since it's, once again, it's a reflection, this length over here is going to have length 1. This is going to be pi over 6 radians. This is going to be pi over 3 radians. So what else do we know about this larger triangle now? Well, we know it's an equilateral triangle. all the angles, pi over 3 radians, pi over 3 radians. And if you add 2 pi over 6's together, you're going to get pi over 3 as well. So it's a 60 degree, 60 degree, 60 degree triangle. And so all the sides are going to have the same length. So it's going to be 1, 1, and 1. And if these two sides are congruent of the smaller triangles, of the smaller right triangles, well, then this right over here must be 1/2. And then this right over here must be 1/2 as well. Now, that's going to be useful for figuring out what this length right over here is going to be. Because we have two right triangles, we could use either one. But if we just use this bottom right triangle here, the Pythagorean theorem tells us that 1/2 squared, let's call this b, so plus b squared, and I'm just pattern matching, a squared plus b squared is equal to c squared, where c is the length of the hypotenuse, is equal to 1 squared. And so we get that 1/4 plus b squared is equal to 1, or subtracting 1/4 from both sides, b squared is equal to 3/4. And then taking the principal root of both sides, we get b is equal to the square root of 3 over 2. So just like that, we have figured out what all the lengths of this 30, 60, 90 triangle are. So b here is equal to square root of 3 over 2. Now, I said this would be useful as we go into the unit circle definitions of sine, cosine, and tangent, and we're about to see why. So here I have two different unit circles. I'm going to use one for each of these angles. So first, let's think about pi over 3 radians. And so pi over 3 would look something like this. So this is pi over 3 radians. And the cosine and sine can be determined by the x and y coordinates of this point where this radius intersects the actual unit circle. The coordinates here are going to be cosine of pi over 3 radians and sine of pi over 3 radians. Or another way to think about it is, I can set up a 30, 60, 90 triangle here. So I'm going to drop a perpendicular. This would be 90 degrees, or pi over 2 radians. And then this angle over here, if this is 60, this is 90, this is going to be 30. Or another way of thinking about it, it's going to be pi over 6 radians. It's going to be just like one of these triangles here. And so the x-coordinate, which is going to be the same thing as the cosine of pi over 3, is going to be the length of this side right over here. Well, what's that going to be? Well, when your hypotenuse is 1, we know that the shorter side, the side opposite the pi over 6 radians, is 1/2. So just like that, we have been able to establish that cosine of pi over 3 radians is equal to 1/2. This right over here is 1/2. That is the x-coordinate where this radius intersects the unit circle. Now, what about the y-coordinate? What is sine of pi over 3 going to be? Well, the y-coordinate is the same thing as the length of this side. And once again, it goes back to being this triangle. If this is 1, this is 1/2, this is 1, this is 1/2. This other side is going to be square root of 3 over 2. So sine of pi over 3 is going to be square root of 3 over 2. So let me write that down. Sine of pi over 3 is equal to square root of 3 over 2. And these are good ones to know. I never say really memorize things. It's always good to know how to derive things in case you forget. But if you had to memorize some, I would highly recommend memorizing these. And then, of course, from these, we can figure out the tangent. The tangent is just going to be the sine over the cosine. So let me write it down here. The tangent of pi over 3 is going to be the sine, which is square root of 3 over 2, over the cosine, which is 1/2. Got a little squunchy down there. And so this is just going to be square root of 3 over 2 times 2 is just going to be square root of 3. So now let's just use that same logic for pi over 6. And in fact, I encourage you to pause this video and see if you can do that on your own. All right, now let's draw a radius that forms a pi over 6 radian angle with a positive x-axis. Might look like that. So if that's going to be pi over 6 radians, you might imagine it's interesting to drop a perpendicular here and see what type of triangle we've constructed. So this has length 1. This is pi over 6 radians. This is a right angle. So this, again, is going to follow the same pattern. This will be pi over 3 radians. And so the sides are exactly the exact same as this top blue triangle here. So we know that this length over here is going to be 1/2. We know that this length over here is going to be square root of 3 y-coordinate. And sine, essentially utilizing the square root of 3, don't like radicals in the denominator, and so you could multiply the numerator and the denominator by square root of 3 if you like to get something like this. If you multiply the numerator and the denominator by square root of 3, you get square root of 3 over 3, which is another way of writing tangent of pi over 6. But either way we're done, it's very useful to know the cosine, sine, and tangent of both pi over 3 and pi over 6, and now you also know how to derive it.
Okay.
So we have depicted here is a unit circle centered at point A, and the point B lies on the circle, and then we dropped a perpendicular from point B to point D. Point D lies on the positive x-axis, and they form this triangle ABD. And they tell us that angle BAD, angle bad, it has a measure of pi over 4 radians. What I want to do in this video is use our knowledge of trigonometry and use our knowledge of triangles in order to figure out several things. So the first thing we want to figure out is what's the measure of angle, what's the radian measure, what's the radian measure of angle ABD, of angle ABD. Actually, let's just do that first, and then I'll talk about the other things that we need to think about. So I assume you've paused the video and tried to do this on your own. So let's think about what ABD would be. We know 2 of the angles of this triangle, so if you know 2 of the angles of this triangle, you should be able to figure out the third. Now what might be a little bit unfamiliar, we're used to saying that the sum of the interior angles of a triangle add up to 180 degrees. But now we're thinking in terms of radians. So we could say that the sum of the angles of a triangle add up to, instead of saying 180 degrees is the same thing as pi radians. So this angle plus that angle are going to add up to pi. So let's just say that this right over here, let's just say measure of angle ABD in radians plus pi over 4 plus this is a right angle. What would that be in radians? Well, a right angle in radians, a 90-degree angle in radians, is pi over 2 radians. So plus pi over 2. When you take the sum of them, the interior angles of this triangle, they're going to add up to pi radians, which is, of course, the same thing as 180 degrees. And now we can solve for the measure of angle ABD. Measure of angle ABD is equal to pi minus pi over 2 minus pi over 4. I just subtracted these 2 from both sides. So this is going to be equal to, let's see, we could put a common denominator of 4. Then this is 4 pi over 4. This is minus 2 pi over 4. And this, of course, is minus pi over 4. So 4 minus 2 minus 1 is going to get us to 1. So this is going to give us 2 pi over 4. So the measure of angle ABD is actually the same as the measure of angle BAD. It is pi over 4. So that angle right over there is pi over 4. Now what does that help us with? So if we know that this is pi length of segment A, what do we know about this triangle? Can we figure out the lengths of segment AD and the length of segment DB? Well, sure. Because we have 2 base angles that have the same measure, that means that the corresponding sides are also going to have the same measure. That means that this side is going to be congruent to that side. I can reorient it in a way that it might make it a little easier to realize. If we were to flip it over, if we were to, not completely flip it over, but if we were to make it look like this, so the triangle, we could make it look like, let me make it look a little bit more like this. Actually, I want to make it look like a right angle. This is because they're not all the same, and isosceles, this side has length, is equal to the hypotenuse squared, is equal to 1 squared, or root of 2. And a lot of folks don't like, which would be, let's see, the numerator will have the square root of 2, and in the denominator, we're cosine and tangent of pi over 4 radians, given all of the work that we have done. So let's first, once again, pause. Pi over 4 radians of this point is the x-coordinate, and the sine of pi over 4 radians is the y-coordinate, sine of pi over 4. So what's the y-coordinate going to be if we want the sine of pi over 4? Well, it's going to be this length right over here, which is the same thing as this length, which is the length of x, which is square root of 2 over 2. Now what is the cosine of pi over 4? And once again, I encourage you to pause. Got it? What's this over 4 going to be? Well, the tangent of pi over 4 is just sine of pi over 4 over cosine. You have square root of 2 over 2 divided by the tangent of this angle is the slope of this line. And we see the slope. For every x we move in the horizontal x is essentially x over x, which is equal to 1.
So what did he say eventually?
Tangent of pi over 4 going to be? Well, the tangent of pi over 4 is just sine of pi over 4 over cosine of pi over 4. Now, both of these are this exact same thing. They're both square root of 2 over 2. So you're going to have square root of 2 over 2 divided by square root of 2 over 2. Well, that's just going to give you 1. And that also makes sense because remember, the tangent of this angle is the slope of this line. And we see the slope. For every x we move in the horizontal direction, we move x up. So our change in y over change in x is essentially x over x, which is equal to 1.
Exercise. Let's practice. DAF. DEF. 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 It's already there. Pi over 3. DEF. So, what do you want exactly? What's the value of tan over tangent pi over 3? So what do I have? This is 8. This is pi over 4. This is pi over 2. This is pi over 2. Well, the tangent is the tangent. Am I correct? This is the tangent. It's 8. But what do we have? Said the tangent of pi over 3 equal to the sine over cosine, which is, here we have sine well, first we got the angle. This angle is pi over 2 because it's all pi equal, it's all 180 equal pi, so I got pi over 2 plus pi over 3 plus, what do I have? Angle EDF. EDF EDF. Am I writing it correctly? Am I correct? Okay. So what's gonna happen is it's gonna be pi minus pi over 2 minus pi over 3. It's gonna give me measurements of E, D, F. So what are we having? Do I use a calculator? Do I use his method? So what's it gonna be? 6 pi minus 3 pi, of course, over 6. I got here 3, so minus, what's it gonna be? Into 2 pi. That's gonna give me 6 pi minus 3 pi minus 2 pi. That's pi over 6, which is 30 degrees. Am I correct? Pi over 6. Degree. I'm gonna have to change the mode. وحدة الزاوية radian 2. Okay, I'm gonna go pi. Where's the pi? Pi minus pi over 2 minus pi over 3. That's pi over 6. I am correct. That's a pi over 6. So what do we got? We got, okay, and 90 degrees. How am I forgetting how to use this? Pi what did I say? Pi over 2. In degrees. Nope, I'm not using this. Yep, it is pi over 2. So this is all correct. Where did I go wrong? What did I say? So 10 this could be in the other half. Am I gonna? Okay. So I got this. I got this side is cosine. The x is cosine of pi over 6. I got the other side, the y. Am I correct? Is sine pi over 3, and the tangent, actually, the tangent is 9 is pi over 2. We take if this is the tangent, if this is the tangent, then if this is the tangent, then this is the, which is sine, which is, if this is the tangent, if it's a tan pi over 3, then it's equal to sine sine what? Wait, this is cosine. Sine 9 pi over 2 over cosine. Wait a second. Over cosine. What did we say? Pi over 6. This is still the cosine. This is still the x. So this is the tangent. Enter an exact value onto the nearest hundredth. But what am I missing here? What am I missing? If we to draw this, when we say this is 8, and we draw another one here, and this is 8, then this and this what's gonna make you out of this? And this is, wait, is this 8 as well? Because it's this is gonna be the same as this. Get 8, 8, but I need to get this, the length of this, which is fairly similar, so it's gonna be the same. I guess this is 4, 4. So this is 8. Let's see. 8 square equal 4 square plus c square. So it's gonna be 16 minus, wait, not 16. 8 square 46 is gonna be 46 minus 4 square 16. Am I correct? 4 square 16. 64 minus 16. 48. So 4 square root of 3. I would go with that. Should we? But wait, what did we establish here? What do we want? The tangent, this one. Yep, this one is 4 square root of 3. Let's find it. 10 by over 3. That's the square root of 3 actually. So where did we get the 4 out? In a way, it's not the same. So this is all wrong. I think this is correct. Let's find this out. Sine by over 2 over cosine by 6. No, different results. So what about cosine by 8? No hints. Am I not getting this right? So this is pi over 2 and this is pi over 6. What does that give me? I remember the rule of sine and cosine. What do I remember? Wait. Yep. Give me a new paper. Cosine rule, and sine rule. Cosine, if I get no, fuck me. Yep. See, this is precalculus. Previous study is precalculus. Precalculus. Opposite. Hypothesis. Hypothesis. Adjacent. Soka. To. Sine of something, tan of something is the opposite over the adjacent. The opposite over the adjacent. this is the opposite, or this the adjacent, which is, what did we say? Over 4. It's the C going to be the square root of 48 over 4, the square root of 3. I am into something, I'm telling you. So it's the square root of 3, not 4. It's the square root of 3. Because, as we say here, you see, very useful. Precalculus from before. God damn it. You see, it's the square root of 3, but how do I get it? Because it's, what did we say? Tan theta is equal to what? Sine theta over cosine theta, which is equal to tan theta, which gives us equal, well, sine theta. Sine theta is the opposite over the hypotenuse. I forgot. And cosine is adjacent over the hypotenuse. What we're gonna do is we're gonna yep. Flip it and make it a product instead of we're gonna make it multiplication instead of what do you call it? Division. Division, is this division? Yes, division instead of division, so it's gonna be opposite over hypothesis over dot product. Gonna flip this here. It's gonna be hypotenuse over adjacent. This will go with this. We're gonna be left with opposite over adjacent. And that's the tangent. I'm sure we're gonna, but I don't know how to I'm gonna go with this, but I'm gonna go with this. Okay, can you give me, because this is way much better. What else? I got the cosine rule, the sine rule, cosine rule. Next question. Okay. What are the coordinates of point A? Point A, this is point A. So I need the x and y. I need the x and y. And the x and y are the cosine and sine. So it's the same angle. This is pi over 2, and this is pi over 6. Because it's the same. It's the same. This is a 90-degree angle. So it's going to be pi over 2. Pi over 2, so I'm going to be left with pi over 6 over here. So what's happening? I need x and y. X and y. X and y is going to be the cosine and sine. Am I correct? So x, this is x. Let's face it, this is x, and this is y. And this is y. So what does it say? It says that this any other, does this give me here? So here to here, this is 1. Is this the middle as well? So this is half. Are you saying this is half? I'm going to go with half. This is half. This says 1 here. But this is also 1. But this is not the same. Look at this. And look at this. So maybe no. I'm going to go with this as half. Why? Look, you know why this is hard? Because he didn't, the guy in the previous videos didn't give me enough information to work with. So what is he saying exactly to work with? But I can do it using my previous precalculus knowledge. Just not sure, because look, this is gonna be, so this is gonna be the tangent of pi over 3, this one. Wait, no, that's gonna be the opposites over the tangent. We want, I have no clue. I'm gonna go with this is half. I'm gonna go with this is half. So x is half. Do we, or this one, we go from, okay, this is 1, this is 1. What are you saying exactly? I'm gonna go, this is half. This cannot be 1. Because look, but if it can, if it's here. Point A is on the following circle. They are the coordinates of point A. So is this one? Give me something to work with. Is this one? So this goes here, and this is 1, and this is 1, so this is half. I go this 1, this half. I got X as half, point half. But the Y, so I got 1 square equal half square plus C square. I got 1 minus half square, half multiplied by half, that's 1/4. That's equal C square, which gives me 3/4. So it's square root of 3 over 2. I'm gonna go with that. Not sure. No, wait. Square root of 3 over 2. Okay. JKL. This one. In radians. Value of cosine. The angle measures of JKL. Pi over 6. Cosine. Pi over 3. So it's still what did we say? How am I gonna get this? Sine, cosine is adjacent over hypotenuse. So adjacent, this is it, over hypotenuse. And this is, what did we say? Yep. Over 1. Cosine is adjacent over hypotenuse. And that's about it. So cosine, no, but this is different. This is here. This is here. So adjacent over hypotenuse, which is half, but this is 18. Again, this is 18. This is not the same. We can multiply this 18 by half and we'll get this. So give me, so I got 0.5 multiplied by 18 equal 9. So I got 9 over 18, which is 1 over 2 again, which is half. Because give me 1, give me 2. It's a half. Am I correct? Guys, come on. I think I missed something here. I think I missed something here. I should have watched. What is the value of sine? Sine, and sine is the opposite over the hypotenuse, which is still half. Nope, it is still half. Still is half. So I'm gonna go watch this again because
ABD. And they tell us an angle BAD, angle bad, it has a measure of pi over 4 radians. Knowledge of what's the radial A grown? The interior angles of a triangle add up to 180 degrees. But now we're thinking in terms of radians. So we could say that the sum of the angles of a triangle, say that plus pi degree angle and interior angle measure minus 4, 1. So this now what is length 1? That have the same measure, that means that the corresponding sides are also going to have the same measure. That means that this side is going to be congruent to that side. I can reorient it in a way that it might make it a little easier to realize. If we were to triangle, we can. So now this is please triangle. And base angles are. If you say that this, we could say that x squared. This x squared is sides. We like having a radical in the denominator over the square root of 2 times square root of 2, and the length of the sine. This is the video definition of trig functions. And this angle, this pi over 4 radians, is forming an angle with the positive x-axis, and where its terminal ray intersects the unit circle, the x and y coordinates of this point are what specify the cosine and sine. So the coordinates of this point are going to be the cosine of pi over 4 radians is the x-coordinate, and the sine of pi over 4 radians is the y-coordinate, sine of pi over 4. So what's the y-coordinate going to be if we want the sine of pi over 4? Well, it's going to be this length right over here, which is the same thing as this length, which is the length of x, which is square root of 2 over 2. Now what is the cosine of pi over 4? And once again, I encourage you to pause the video to think about it. What's this x-coordinate? What's the x-coordinate? The x-coordinate is this distance right over here, which is once again going to be x, which is square root of 2 over 2. Now, what is the tangent of pi over 4 going to be? Well, the tangent of pi over 4 is just sine of pi over 4 over cosine of pi over 4. Now, both of these are this exact same thing. They're both square root of 2 over 2. So you're going to have square root of 2 over 2 divided by square root of 2.
So the cosine is the x, and the sine is the y. That's what he is saying. So back again at this, the sine of pi over 4. Here's the question: how do I know that this is the x and this is? So this must be the hypothesis. What did he call the hypothesis? The hypothesis. This is the hypothesis. So This is the x, so the sine is the y. This is the sine. So if this is 11, you know what? This is 11. Am I gonna get 11? Do you want me to write 11? Is that it? Because this is the x, so the sine is the y. The sine is the y. The y. The y. Is this the y? So, how are we going here? So this is the y. What is this? This is double this. This must be 22. 22, so 22. I'm gonna go with that. 22 square, 11 square plus c square. It's 22 square. 22 square minus 11 square. 300 and 11 square root of 3. It's 11 the square root of 3. Show me the steps. How do we know the triangle is? Okay, so this is 11, so it's 11. The sine of an acute is the hypotenuse length, which is the double. He's using the same mechanics that I used. The sine is the opposite side length of the hypotenuse. He's using the same mechanism. He's not saying it's x nor it's y. He's using the same mechanism, but he didn't give any introduction to it. So let's jump. I've already done this. Okay. Leave this till tomorrow. So I got algebra, precalculus all lined up. I'm gonna have to pray, you guys. I don't know if I should leave the rest till tomorrow. I get no idea. So I'm gonna have to pray first. Sorry. Allah. Allah.
So let's explore the unit circle in a little bit more depth. So let's just start with some angle theta. And for the sake of this video, we'll assume everything is in radians. So this angle right over here, we would call this theta. And now let's flip this, I guess we could say the terminal ray of this angle. Let's flip it over the x and y axes. So let's just make sure we've labeled our axes. So let's flip it over the positive x-axis. So if you flip it over the positive x-axis, you just go straight down, then you go the same distance on the other side. You get to that point right over there. And so you would get this ray. You would get this ray that I'm attempting to draw in blue. You would get that ray right over there. Now what is the angle between this ray and the positive x-axis? If you start at the positive x-axis, well, just using our conventions that counterclockwise from the x-axis is a positive angle, this is clockwise. So instead of going theta above the x-axis, we're going theta below. So we would call this, by our convention, an angle of negative theta. Now let's flip our original green ray. Let's flip it over the positive y-axis. So if you flip it over the positive y-axis, we're going to go from there all the way to right over there. And we can draw my angle radians. Well, we know if we were to go all the way to the from the positive x-axis to the negative x-axis, that would be pi radians, because that's halfway around the circle. So this angle, since we know that if that's theta, this is theta right over here, the angle that we want to figure out, this is going to be all the way around. It's going to be pi minus. It's going to be pi minus theta. Notice pi minus theta plus theta. These two are supplementary, and they add up to pi radians, or 180 degrees. Now let's flip this one over the negative x-axis. So if we flip this one over the negative x-axis, you're going to get right over there, and so you're going to get an angle that looks like this. And now what is going to be the measure of this angle? So if we go all the way around like that, what is the measure of that angle? Well, to go this far is pi, and then you're going another theta. This angle right over here is theta, so you're going pi plus another theta. So this whole angle right over here, this whole thing is pi plus theta radians. So pi plus theta, let me just write that down. So this is pi plus theta.
Yep.
Now that we've figured out these kind of, these have different symmetries about them, let's think about how the sines and cosines of these different angles relate to each other. So we are the x-coordinate is cosine of theta, and this value right over here on the y of our would be of sine. At this point right over here, the x-coordinate is cosine of pi minus theta. That's what this angle is when we go from the positive x-axis. This is cosine of pi minus theta, and the y-coordinate is the sine of pi minus theta. And then we could go all the way around cosine, pi plus theta. And now how do these all relate to each other? Well, notice over here, out here on the right, this cosine, pretty interesting, of theta is equal to the negative sine of theta. Equal to the not above or below the x-axis, you're going to get the negative value for the sine. And we could do the same thing over here. How does this one relate to that? Well, these two are going to have the same sine values, right? The sine of this, the y-coordinate, is the same as the sine of that. So we see that this must be equal to that. Let's write that down. So we get sine of theta is equal to sine of pi minus theta. Now let's think about how do the cosines relate. Well, by the same argument, they're going to be the opposites of each other, where the x-coordinates are the same distance but on opposite sides of the origin. So we get the negative colors are equal to the. And now finally, let's think about how this one relates. Well, here our cosine value, our x-coordinate, is the negative, and our sine value is also the negative. We've kind of flipped over both axes. So let's write that down. Over here, we have sine of theta plus pi, which is the same thing as pi plus theta. is equal to the negative of the sine of theta. And we see that this is sine of theta. This is sine of pi plus theta, or sine of theta plus pi. And we get the cosine of theta plus pi. Cosine of theta plus pi is going to be the negative of cosine of theta, is equal to the negative of cosine of theta. So even here, and you could see, you could keep going. You could try to relate this one to that one, or that one to that one. You can get all sorts of interesting results. So I encourage you to really try to think this through on your own, and think about how all of these are related to each other based on essentially symmetries or reflections around the x or y axis.
And this is statics all over. The beginning of statics. If you've studied engineering, mechanical or civil, I don't know about the other, but it's statics. It's not statistics, it's statics. Statics, this one. Let's check it out. This one, what is it called? Statics. Yep. This one. Engineering statics. This is it. This is all about it. This is sine, cosine. This is precalculus. We'll come to that later in the future years. We'll cover everything I want to cover. So back to where we are. Tangent.
In the previous video, we explored how the cosine and sines of angles relate when the just think a bit of a reminder is equal to of an angle and of the terminal ray right over here. If we remind ourselves slope is rise over run. It is our axis, or the terminal theta right over ray here. I should to that the tangent of an angle is equal to the slope of the terminal ray. Of course, the other side of the angle is going to be the positive x-axis based on the conventions that we've set up. Well, let's think about what the tangent of theta plus pi is in terms of sine and cosine. So the tangent, let me write this, pi plus d, that's equal to the sine of pi plus theta, or theta plus pi, over the cosine of theta plus pi. And in the previous video, we established that the sine of negative theta and the cosine of theta plus pi, negatives cancel out, and we're left with sine theta over cosine. Pretty good about that. Now, what about this? What about the points or the terminal rays right over here? Right, this is the t thing as the sine of negative theta over the cosine of sine of negative sine theta. Opposite of negative are the same, so we're left with negative sine, which is the same thing, which is equal to negative tangent theta. And so we see here, if you make the angle, if you take the negative of the angle, you're going to get the negative of the tangent. And that's because the sine, the numerator, in our definition of tangent, changes signs, but the denominator does not. So tangent of negative theta is the same thing as negative tangent of theta. Now what about this point right over here? Well, over here, relative to theta, when we're looking at pi minus theta, so when we're looking at tangent of pi minus theta, so tangent of pi minus theta, that's sine of pi minus theta over cosine of pi minus theta. And we already established in the previous video over here equal to, it's the opposite of cosine of theta. It's the negative of cosine of theta. So this is negative cosine theta, or the negative tangent of theta, which makes sense. This ray should have the same slope as this ray right over here. And we define the rays their images. If you take change 180 degrees not change of theta plus pi, but if you take the negative of your angle, then you're going to get the negative of your tangent, or if you were to go over here, and if you were to take your angle, hopefully you're going to use it's really helpful.
So tan here and here are minus. It's going to be in this second quarter and the fourth quarter are minus, and in the third quarter and the first quarter are positive, the tan. And here positive, here positive negative, so here the y, which is the sine, am I correct? No, the y, right, the y is going to be the cosine is negative. So the y is negative, and the sine, which is the x, is positive. So the sine, it's very confusing, but with practice you're gonna get the hang of it. I am gonna get the hang of it with practice. So
let's say that I've got some angle theta right over here, and I'm ray is determined before about it is of what I think that of way of thinking length and so this makes is an let me for hypotenuse. So if I think about the definition, well, with theta, so it's other sine hypotenuse the theta. So that side. So this is all a little bit of review, just showing how the units. But now let's do theta to this pi over 2 plus pi over degrees. Angle right plus is theta. Before I work it out, where 2 is. We know from the unit circle definition, the sine of this angle, which is theta plus pi over 2, is the y over here. Or another way of thinking about it, it's the length. It's the length of this line in magenta. This right over here is the sine of theta. Looks like we did it, or is we relative with the one. And this the hypotenuse. That was pretty neat. To after this video is to how what sine of theta really relates to, or what cosine of theta plus pi over 2 might relate to. So I encourage you to explore that on your own.
that's fine. Plus 90 degrees. Well, the last bit.
Hypotenuse, and in this case, of course, our hypotenuse has length 1. This is a unit circle. Well, cosine deals with adjacent and hypotenuse. So we could say that the cosine of this theta, so the cosine of that theta, is equal to the adjacent side, the length of the adjacent side, which we already know is sine of theta plus pi over 2. Let me write it this way. Sine of theta plus pi over 2 over the hypotenuse, which is just 1, so that doesn't change its value. So that was pretty neat. Just like that, we were able to come up with a pretty neat relationship between cosine and sine. The cosine of theta is equal to sine of theta plus pi over 2, or you could say sine of theta plus pi over 2 is equal to cosine of theta. Now what I encourage you to do is, after this video, see if you can come up with other.
So
now, what I want to explore in this video, and I guess this is the interesting part of the video, is can we relate sine of theta plus pi over 2 to somehow sine of theta or cosine of theta. And I encourage you to pause this video and try to think this through on your own before I work it out. Well, let's think about what sine of theta plus pi over 2 is. We know from the unit circle definition, the sine of this angle, which is theta plus pi over 2, is the y coordinate. It's that. It's this value right over here. Or another way of thinking about it, it's the length. It's the length of this line in magenta. This right over here is the sine of theta plus pi over 2. So that right over there. Now, how does that relate to what we have over here? Well, when you look at it, it looks like we just took this triangle and we just we rotated it counterclockwise by 90 degrees, which is essentially what we did do, because we took this terminal side and we added 90 degrees to it, or pi over 2 radians. And if you want to get a little bit more rigorous about it, if this whole white angle here is theta plus pi over 2, and the part that's in the first quadrant is pi over 2, then this part right over here, that must be equal to theta. And if we think about it, if we try to relate this side that I put in magenta relative to this angle theta using the SOHCAHTOA definition, here, relative to this angle theta in yellow, this is the adjacent side. So let's think about it a little bit. So what deals with the adjacent and the hypotenuse? And in this case, of course, our hypotenuse has length 1. This is a unit circle. Well, cosine deals with adjacent and hypotenuse. So we could say that the cosine of this theta, so the cosine of that theta, is equal to the adjacent side, the length of the adjacent side, which we already know is sine of theta plus pi over 2. Let me write it this way. Sine of theta plus pi over 2 over the hypotenuse, which is just 1, so that doesn't change its value. So that was pretty neat. Just like that, we were able to come up with a pretty neat relationship between cosine and sine. The cosine of theta is equal to sine of theta plus pi over 2, or you could say sine of theta plus pi over 2 is equal to cosine of theta. Now, what I encourage you to do is, after this video, see if you can come up with other results. Think about what happens to what sine of theta really relates to, or what cosine of theta plus pi over 2 might relate to. So I encourage you to explore that on your own.
Remember, this is a revision to me. A revision that will open advanced courses for me. Advanced courses that will get me to where I want to be, which is cos theta plus sine theta plus pi over 2. So I'm on a hurry so that I could finish these courses quickly and jump into the core courses so that I could, well, there is a lot of things I could do with these courses.
One angle whose tangent is half is 0.46 radians. So we're saying that the tangent right over here is, so the tangent, let me write this down. So we're saying that the tangent of 0.46 radians is equal to half. And another way of thinking about the tangent of an angle is that's the slope of that angle's terminal ray. So it's the slope of this ray right over here. That makes sense that slope is about a half. Now, what other angles have a tangent of 1/2? So let's look at these choices. So this is our original angle, 0.46 radians, plus pi over 2. If you think in degrees, pi is 180, pi over 2 is 90 degrees. So this one, actually let me do it in a color you're more likely to see. This one is going to look like this.
So pi minus 6, which is 180 minus, that's correct. Pi plus, correct. And 2 pi minus, then this is correct. This is wrong.
It's going to look like pi, thing like slope of the 46. So that's going to take us, if you add pi to this, you're essentially going halfway around the unit circle, and you're getting to a point that is, or you're forming a ray that is collinear with the original ray. So that's, when you just look at this, the terminal ray. And in previous videos, when we explored the symmetries of the tangent function, we in fact saw that if you took an angle and you add pi to it, you're going to have the same tangent. And if you want to dig a little bit deeper, I encourage you to look at that video on the symmetries of unit circle symmetries for the tangent. If of x-axis right up here. Now this one, you're 4,6. Circle once, and you get to the exact same point. So you add 2 pi, you only have the same tangent back around to the exact. This is definitely also going to be true. Going to take us 0.8. These pi is 180, pi over 2 is 90 degrees. So this one, actually let me do it in a color you're more likely to see. This one is going to look like this. You immediately see that, in fact, they look like between them, we're going to have the same tangent. They don't have the same slope. Minus 0.46. So that's exact way around 0.4, something like 46 that we have subtracted. Another one array axis here of the top of this, like, so we could rule that one out as well. So we they look like the negatives of each other. So we could rule that one out. So we could rule that one out as well. 0.46 plus pi, or pi plus 0.46. So that's going to be halfway. That is collinear. So that's that angle right over here. So pi plus this collinear as point for the tangent. So I videos when we and you add pi to dig a little bit symmetries of the other choices. 2 pi minus 0.4.
Okay. So what he's saying is here it's going to be positive, the same as here, and 2 pi, this is 2 pi plus 0.46 is the same as this one. It's the same. It's this one. This is 0.46 or 2 pi 0.46.
So 2 pi.
Let's do some exercises and finish with precalculus today. On the following unit circle, theta is in radians and tan theta equal minus 99 over 1 equal minus 9.9. Okay. Without a calculator, evaluate the following expressions to the nearest hundredth or as an exact ratio. So what do I have? What am I working with? Let's do this. Tan pi plus theta. Pi plus theta. Pi plus theta, which is this here. It's going to be here. So it's going to be positive, positive. So this is positive and this is positive, which means it's, I don't know, 9.9. It's positive. 9.9. And here also it's 9.9 because it's going to be positive, positive. They're both positive. Am I correct? And theta, pi here, pi plus theta, it's going to be positive, positive. Wait. Negative, negative. Wait. It's going to be negative, negative. Wait. Positive, positive. Positive, negative. Negative, negative. Positive, negative. So here positive, negative. positive, positive, negative x, positive y. So here is minus, wait, yep, I'm gonna go with this. I'm gonna go with this. Wait, what are you talking about? (9.9). Expression tan theta, tan pi plus theta. This is pi over 2, and this is pi. Pi plus theta is gonna be here. So it's gonna be minus 0.1 and minus 0.99. Okay? Which is gonna be minus and minus. Minus over minus is plus. So this is plus also, and this is plus because it's plus. Sorry. Again, what are you talking about? It's gonna be, well, tan pi plus theta is gonna be equal to, which is the theta, I don't care about the theta, it's gonna be minus 0.99 over minus 0.1. Minus and minus will go together. This will give me 9.9. I guess. So, and 2 pi plus theta, tan 2 pi plus theta is going to be 0.99 over 0.1, which is going to equal 9.9. What's happening? 9.9, 9.9. This is gonna be here. What changed? What changed? Still is still the opposite over the adjacent. The adjacent, which is this one. So here it's gonna be this. It's gonna be here. So the adjacent is this one, and the opposite is this one. And theta. (0.1). This is the x. This is the x, which is this one, and this is the y. It's 1 again. It's 1. So 0.1. 0.1. It's gonna be the same here. Here we don't care. Here it's gonna be minus and minus. Here plus plus. Here minus and minus. Minus 0.1 and minus 99. Still the same. This is the x, and this is the, and this is the x, which is 0.1, and this is the adjacent, which is minus. I'm gonna still go with this. Come on. What's going on? What's going on? Here, it's gonna be like this. So, x 0.1 and y 0.99. And here, oh god damn it, here it's gonna be 0.1 minus and 0.99. So what's happening? Minus over minus, positive. It's gonna be positive. That's not positive, so minus is positive. It's positive. And this is positive. Minus 9.9 is this. What is this? Do we have to put point here? Yep, no such thing. Show us the what are you talking about? Why is it here? This is by plus theta. Because this is by over 2. What are you talking about? Pi plus theta. This cannot be right. This cannot be right. This cannot be right. Wait. This is pi. And this is 2 pi. And this is pi over 2. Which leaves this, I think this is pi over 3. Again, tan pi plus theta. What are you talking about? This is the theta. Yes, this is the theta. I'm gonna need Claude on this. Claude. Right, both answers are in either side. Point of this problem. Situation. Ah, sine theta. Is it sine theta? Wait. Yeah, tan theta. So this is minus. This is minus 90. But wait. Tan theta. Wait. Tan theta is minus 99. Which means it's this one. Really, it's not this. Right. Quarter one. So tan quarter 10 rotating by half a turn. By half a turn flips both coordinates. But tangent is wait. Are we doing like this? So this is theta plus pi, which is gonna be here because it's plus pi, and this is the pi. So it's gonna be here. 2 pi. It's gonna land here. If we add 2 pi, it's gonna land here again. So he's considering this to be pi theta. This to be theta. He didn't. This has nothing to do with this as being 2 pi. This is pi. Yeah. So to I see a plus sign X. Because it's just say on there. I can't tell what this is meant. I mean, this has nothing to do with the answer because it wasn't considered as if pi plus theta is in the Q3. Q2 is right. Let me show you. Your theta has a cosine theta, positive, and sine theta equal negative. So theta sits in Q4 close to the negative y-axis. Adding half run flips both coordinates. Render stand but how am I suppose that's what wanted according to me pi plus theta is in the third quarter. But I didn't consider that theta was actually on Q4. So what I'm trying to say, how would I know when to consider this or that in an English? I don't know. Let's jump in. Let's move on. Okay, so minus. Okay. Unit circle theta is in radians. Okay, so now it's in the fourth. What's pi plus theta? So we're gonna add pi, which is here. It's gonna be here. We're gonna add pi, so theta is gonna be here. Okay, so it's gonna be also minus wait, the x is gonna be minus, the y is gonna be positives, minus, and it is, what did we say? It is opposite over the adjacent. The opposite which is y, the x is the adjacent. Is it this? Seriously, is it this or is it this? Because now it's this. It's this. So the x is this. This is the x, which is the opposite. The opposite is always x. So it is here minus 0.83 over 0.5. Okay, 2 pi minus theta. So what we're gonna do is it's gonna have 2 pi minus theta. Minus theta. Where is it gonna land? So wait. 2 pi minus theta. Could it be here? So minus theta. So this is 2 pi. 1 pi is going to be here. 2 pi is the same where it is 2 pi. Full circle. Minus theta. Minus theta. Just gonna give it back. So it has to do with theta. So it's here. Is this the theta? Or is it this the theta? In radians. This is the theta. This is the theta. This is the theta. So if we are go full pi plus theta, which is gonna go over how many? One pi plus theta. It's the same. It's gonna go over how many quarters? 2, 3. So it's gonna go 1, 2. Wait. 1, 2, 3, 4. So it's gonna go. It's went here, and starting from here, it's gonna go 1, 2, 3, 4. So again, oh my god. Oh my god. Wait. This is the theta. This is the theta. So 1 by plus the theta, it's going to be here. This is the 1 by, because it's going to go over 1 by plus the theta. This is the theta. It's going to 1 by plus the theta. This is the theta. This is the theta plus 1 by. So it's here. So this is, we're finished with this one. But what we're having is 2 by minus the theta. So 2 by is going to go 1 is going to go here, 1 by, and then it's going to go here, 1 by again. So it's here again. Minus the theta. Which is going to give me all over, back again, because it's the theta. Back again, so it's here. I guess it's here. So it's a minus as well. But different. I'm going to go 0.83 minus not minus, over minus 0.55. Nope. Good question. There is a systematic rule, so you're not guessing. Adding by is always moves you to the diagonally opposite quadrant. Theta in Q1 plus the what gives us pi plus theta in quadrant 3. Indeed, in quadrant theta in quadrant 4 plus pi in quadrant 2. Okay, so Q4 gives us quadrant 2, which makes sense here. We're still in quadrant 2, but the third one minus theta. If we are to add 2 by, we are going to end up at the same Q. Exactly. Minus the theta. full turn. I know. So that's minus the theta. So minus the theta, what? We're gonna end up the same here. It's gonna look like full circle. Gonna look like the same. Minus the theta. Minus the theta is gonna give me 0. 0y, 0. So it's gonna be 0. I guess 0. The tangent is gonna be, wait, 0 over 0, 1, I don't know, 0. Doesn't matter. Because look, here we just minus the theta, minus this theta. We're gonna land up here. So the x is gonna be what? 1. The x is gonna be 1. The y is gonna be 0. What about the tangent? What is it gonna be? 1. Two pi minus 0. Minus theta. Cosine, 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 it's not sine, cosine. And what did you say? Cosine is the y. Am I correct? Cosine is the y. It's not tangent anymore. So we're gonna end up here, and the cosine is minus 0.55. Okay, this we're gonna go here, minus the theta, the cosine, which is the y, equals 0. Wait, isn't which is to say, wait, what do I have here? Sine is the opposite. The sine is the opposite over the hypotenuse. The sine is the opposite over the hypotenuse, which is to say it's the x. It's the y. Right. Very good. Well, careful. It's the other way around. Cosine is x. Cosine. Sorry. Okay. So cosine is minus 0.83 here because it's here, both minus minus, and I got, if we are to turn here, going back here, minus the theta, minus the theta, this is the theta, minus the theta. Yeah, this is going to be here, which means that the cosine, which is the x, is going to be what? .83, because the y is 0, definitely. So this is, wait, 2 pi, 2 pi. Why is there 2 negative? 0.88. Sorry guys, I have to take a call. See how ridiculous this? X. Wait, this is x. Hello. Huh. Okay. That's according to Claude. According to Claude. Plus theta buying plus theta in quarter 2. So it's in quarter 2. Okay? Now, what about theta? What about pi minus theta? What? Wait. This is the x, and this is the y. But this is the theta. It's not this. This is the theta. This is the theta. I don't know. So we're gonna go with this one. The cosine is the adjacent over the hypotenuse. This is the hypotenuse. We don't know what's the hypotenuse, but this is the j. This is cosine. It goes here. Shh. Wait. Plus 1 by it's gonna be here. Theta. This is gonna be. So this is we're sure of. 83. Because here it's gonna be both negative. And he says cosine is the x. So the x is the same. Am I correct? What about minus theta? It's a mirror flip. No. So for a tangent. Nope. It's 2 by minus theta. Since there. And so it's 88, 83, man. 83. God damn it, man. Okay, I'm gonna have to do this again. On the following unit circle, theta is in radius. It's in quarter 3. Which of the two following is sine theta? So sine theta here. Sine theta here. So the sine theta here is actually is the y, and the y here is minus. So it's gonna be minus. Okay? So minus theta. But it's in quarter 3. It's in quarter 3. Are we going? Plus, because this is the theta, it's gonna be, nope, not this one. Nope, nope, nope. I need sine to be, which is here is theta. What are we doing? Sine theta by minus theta. So by, it's gonna be here. Minus theta is gonna go back to where it is. Am I correct? This is theta. This is theta. So by minus theta, no. 2 by minus theta, 2 by minus theta. Nope. 2 by plus theta. Yes, 2 by plus theta. And sine 2, okay. Pi over 2 minus theta. Pi over 2, which is pi over 2, which is this one. This is pi over 2 minus theta. I guess, yes. Yep. God damn it. It can't be this. It can't be 2 pi minus theta. This is theta. It can't be this. And it can't be, and it can't be pi minus theta. Pi is this one. It's here. Pi is here. Minus theta. It's gonna land here. Here. What if we take it here? Here, the y is gonna be minus, and the y is sine. So this one. So what are we saying? Pi minus theta. Pi minus theta. So, God damn it! You're gonna have to do this again. On the following unit circle, theta is a radians. This is the theta. Okay. Are equivalent to tan theta. Tan theta. Here, minus over minus, so it's positive. Flip it over the x-axis. Nope. Pi plus theta. Pi plus theta. It's gonna end up here, I guess. And 2 pi plus theta. 2 pi here. Plus theta. Yep. pi minus theta, pi. Can I end up here? No. So, guess, let's do it again. Let's do it again. On the following, this is the pi. Okay. It's positive. Wait. Cosine is minus. Actually minus. Cosine is minus because both y, x and y are minus. Cosine is x and it's minus. So it's minus. So cosine plus theta, pi plus theta. You have 2 and it's gonna end up here in the third, and here is positive, no way. So pi minus theta, pi minus theta, it's gonna go here, here, and it's gonna end up here, and here the x is positive and the cosine is x, so no, it's a minus. It's a minus, so no. Choose two answers. I'm left with this one, which gonna put me here, and the x is minus here, and 2 pi plus theta, which is the same, so I'm gonna go with this. Okay. So theta here, tan, okay, tan theta minus pi minus theta, so this is pi minus theta is gonna give me here, and here the x is minus and this is positive, the y is positive, so I'm gonna end up with minus 4.9. 4.9. Okay, tan 2 theta 2 pi minus theta, this is gonna be here, minus theta is gonna be here, so the x is positive and the y is negative, which is gonna leave me with minus 4.9. Okay, this is the theta. This is the theta. Okay. Sine. Which two of the following expressions are opposite of sine? Do I have a minus? Okay. So sine theta. So here sine, cosine is x, sine is y, here y is positive, y is positive, so I need y to be positive, I need y to be negative, which is here, here, and here, and here. So I'm gonna go, nope. Oh well, I can. Flipping it over the x-axis. Well, this might be it, but 2 pi plus theta, it's not the opposite, it's the same. 2 pi minus theta, I guess yes. 2 pi minus theta. It's going to be, yep, the opposite. And sine pi minus theta. Pi minus theta. No, I don't think so. So I'm going to go with this. I'm going to go with this too. Pi plus theta. Okay, without a calculator, evaluate the following. Cosine, this is the theta. Theta, pi plus theta. This, so here is pi plus the theta. It's going to go 1, 2, 3, and here. It's going to be here. Exactly the opposite. Which is going to give me, and cosine is the x, and here the x is negative. So it's going to be minus 0.83. And 2 pi minus theta, 2 pi, this is 2 pi minus theta, it's going to be 1, 2, 3. It's going to be here, and here it's going to be 0.83. The cosine, it's going to remain the same. Okay. Trig values of special angles. Find the following trigonometric values. Cosine, express your answer exactly. 225. I got 360. Well, that's pi. Well, 200. Wait. That's 180. Wait, that's 180. 90, 180. Do we use a calculator or what? Yeah. So your answer is exactly. So and 90, 200, 180 and 90. And 260, 270. Wait. 260 minus 90. 170. That's not 270. That's 180 plus 45 degrees. But he wants the cosine of it. How am I going to find the cosine of it? Using a calculator. Am I allowed to use a calculator here? How am I gonna use? How am I gonna? Trig values of special angles. I think I'm gonna use a calculator. Cosine 225. Right. Degrees. Cosine 225. Okay. Square root 2 over 2. And sine 225 degrees is still the same. Okay. So radian cosine. I think it's the same. Cosine 5 pi over 4. And are you gonna memorize this, you guys? I don't think so. 2 pi over 3 sine 2 square root of 3 over 2. Actually, there. Cosine 2 pi over 3 minus f. Is that f? It's not to be. Okay. Degrees cosine 330 sine 3 minus f. I am not gonna memorize this. So lesson 3, I don't think so. I think this is enough for today, you guys. See you in a bit. So this is got precalculus and algebra here. Yep. Okay. Well, that'll be it for today's precalculus. More mathematics for today. Gonna jump into programming.